The twin prime conjecture, a logical breakdown. Okay, let's just dive right into this explainer because the twin prime conjecture is honestly one of the oldest, most deeply fascinating unsolved puzzles in all of mathematics. But today we're going to meticulously unpack a very specific, incredibly bold attempt at proving it straight from our source text. We are going to reconstruct the exact architecture of this logic step by step just to see how a towering mathematical conclusion is built entirely from the ground up. 11 and 13. Look, we're skipping any long, drawn-out preamble today because this massive mathematical puzzle starts completely grounded in two universally understood numbers. You really don't need a degree in advanced number theory to grasp this. The argument deliberately anchors us with this concrete, tangible pair before any of the deep abstraction even begins. Right out of the gate, the text establishes the absolute rules of the game. Twin primes must differ by exactly 2. And they cannot be divided by any other number than 1 and themselves. 11 and 13 perfectly meet these strict conditions. First, obviously, they're separated by a difference of exactly 2. And second, they're prime. You absolutely cannot divide them by anything else. Everything that follows in this argument is meticulously designed to legally, undeniably satisfy these two specific constraints. Now, instead of just randomly hunting around for more primes, the author introduces an active 3-step mechanical engine to literally engineer them. Step 1, you take your starting prime. Step 2, you add a number divisible only by 2 and 5. And step 3, boom, you get a brand new prime number. This completely transforms the approach from simply observing numbers in the wild to actively manufacturing them. The claim here is that this mechanical engine will just keep pumping out prime numbers indefinitely. And in practice, this mechanism is brilliantly simple. You literally just put a 1 in front. Adding a number divisible only by 2 and 5, like 100 for example, is functionally the exact same thing as just slapping a 1 onto our original base pair. Notice how elegantly 11 becomes 111 and 13 becomes 113. It completely takes the intimidation out of the math, right? You aren't doing complex division, you are quite literally just stacking ones. By consistently adding values like 10, 100, or 1000, this wild architectural pattern emerges. 11 and 13 become 111 and 113, which then become 1011 and 1113. We start to see a literal tower of numbers. Each layer just adds another 1 to the prefix, creating pairs that continue to differ by exactly 2. This visual stacking perfectly satisfies the very first condition of our twin prime definition. But you might be wondering, what about the second condition? How do we actually know these newly generated numbers don't have other hidden divisors? Well, this right here is the logical linchpin of the entire document. Because we added a number composed only of 2s and 5s, the resulting sum is inherently protected. The argument uses this specific divisibility rule as an impenetrable shield, guaranteeing the purity of the newly generated prime. It ensures the new sum simply cannot be divided by 2, 5, or the former prime. This all culminates in a truly monumental claim. Any amount of 1s and any amount of 1s plus 2 are by definition twin primes. I mean, this is the grand payoff of that mechanical engine. If this rule holds up, that adding these specific prefixes always protects the prime nature of the number, then the physical length of the number doesn't even matter anymore. You could literally have a string of 1s stretching from here all the way to the moon, and according to this framework, it would absolutely be a prime number. Swap that final digit to a 3, and you've got its twin. The text then hits its ultimate mathematical climax with a highly confident QED, boldly signaling the conclusion of the proof. Now, for those of you familiar with mathematical proofs, quod erat demonstrandum translates roughly to which was to be demonstrated. It is, for all intents and purposes, the ultimate mic drop in mathematics. Dropping a QED here signals unwavering confidence that the logic is totally sound, the mechanical engine works flawlessly, and the twin prime conjecture has been definitively solved. It's just a moment of pure, unabashed triumph. But just when the rigid mechanics seem completely settled, the text takes a sudden, much slower philosophical pivot. It draws a stark contrast between an ongoing number of primes and a true infinity of them. And honestly, this is where the material gets wonderfully complex. Just a single sentence after declaring victory with that QED mic drop, there's a massive pullback. The proof only guarantees an ongoing number of these twin primes. It draws a hard line in the sand between a process that can continue forever and the actual tangible concept of infinity itself. It completely shifts the entire tone from a strict mathematical proof to a deep philosophical debate about what numbers actually represent. So this entire step-by-step journey ends with a staggering caveat. The author entirely rejects the word infinity, claiming it is mathematically ill-defined. They aren't doubting their own mechanical proof, not at all. They still fully believe they can generate these numbers endlessly, but they are entirely rejecting the established mathematical language we use to describe that endlessness. They are essentially saying, hey, my math is perfect, but the dictionary is wrong. Which leaves us with a totally fascinating final thought derived straight from this conclusion. If the words we use to describe endlessness are actually flawed, does an ongoing puzzle ever truly reach infinity? We started this explainer looking at a wonderfully simple mechanism for adding digits to the numbers 11 and 13. But the text ultimately forces us to question the very framework of mathematical language itself. If a process is ongoing, but we cannot legally call it infinite, how do we define the limits of human knowledge? It is an incredibly provocative place for a mathematical proof to land, and it leaves us rethinking not just prime numbers, but the very words we use to understand our universe.